The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
Now level.
Demonstrate that the surface you're using is flat, and none of you have ever done that. Why, I wonder?
If I used a liquid level, you would say that the surface isn't flat because water curves around Earth, correct?
If you'd use a patch of water the size of a table, that'd be fine.
Okay, so
And a long level, a level the size of the table, that would be sufficient.
Okay. Wait, so you're saying if I took a 6-foot level and put it on a table, that level and table are perfectly straight lines?
I'm not really sure where you're going with this.
Okay.
I know. It would depend. It would depend on the actual experiment, wouldn't it? We would have to see it, but I would rather you show me an actual experiment.
I'm asking
than
you
propose some hypothetical one that you might do at some point in the future if we don't object too much.
Okay,
What's the point of this? Are you proposing some
Objection
Objection on the table. Go ahead.
Right. If you had a mile-long level that was perfectly flat, straight, and laid it on water, one side making contact with the water, the other side would be 8 inches above the water. Okay?
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
Why? Because the geoid dictates that the gravitational force orientation is such that it actually gravitationally is going downhill, but physically going uphill.
The auto level or the water level? Which one is most level to you guys?
Can I ask a new question, please?
Can I get somebody to answer a question? Which level?
The water level.
Go on.
Water level, Bill.
The water level is the most level.
The water level will show you level.
Okay.
If you'll take your auto level then to the center of this array of level points that you've established, set it at the center, and then shoot both ends.
Yep.
You'll find out that they're dropping.
What? Both ends of the water level lower than the middle.
We got a hump.
You've got a hump.
Absolutely.
It's a hump.
We got a humpus.
Yeah.
You got a hump face.
Nice. What about if you stood at one end? What happens then?
You'll shoot above the far. You'll shoot above the far one every time.
So that's a drop.
Yep.
Would you not get stuck at the middle bit that was higher?
It's a drop it would be a drop any direction you go. Earth is always dropping away from you.
So the water, you think the water level drops away from you?
Yeah, I know it does.
Like a measurable from the horizontal, like you say, right?
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
If you'll do what you said, set your auto level up at the center and shoot both ends, or set it up at either end and shoot to the far end, you're going to find out that it won't match the water level.
Right, so it's a drop. Now, can I ask you, because you sound like you're a bit knowledgeable, what do you call a change in vertical in surveying? Like if there's a vertical distance change, what's that called?
It's elevation, and it's measured from sea level.
You've just said that the water level changes in elevation from the point you're at.
The water level does. Yes, the water level will. Absolutely.
It's not establishing a level.
Wait
a minute. I think you might have got... Whoa, yeah.
Hold on.
Go on.
Hold on.
Take a mulligan on that one. Let's try again.
Don't overtalk. Yeah. Don't overtalk me.
Don't Penrose yourself.
The water level is going to establish the same elevation at every point.
Okay, so it's not a measurable drop from the horizontal then, like you just said.
It certainly will be. It certainly will be. The water level is not measuring a horizontal.
A measurable change from the horizontal is a change in elevation, isn't it?
Potential. It's measuring equal geometric or gravitational potential.
So it is a drop, and it's a measurable drop from the horizontal, which means a vertical distance change, but it's not a vertical distance change because the elevation stays the same. This seems a little bit tricky for you, here, Blue.
I think you're double speaking, Bill.
No, I think that was you.
Did.
I think you're double speaking.
No, I think
It was your words.
you're conflating elevation with curvature, surely.
He was a humpist a minute ago, and now
Elevation
you
is
turned to
always-
a droppist.
It is not. Wait a minute. The elevation from the water level is always going to be the same.
You look at the chat. I'll post it again.
What, some more pictures?
Well, no, this shows that the St. Lawrence River has been the U.S. Geology Society has measured this river to be 8 meters higher at the mouth than at the source. Over 550 miles.
Wouldn't the source be up the top of a hill somewhere?
So, hold on, it's 8 meters, yeah? What about, so how far is that? 500 miles?
550 miles, yes.
Well, how much curvature is in that as well?
The curvature would be...
It's more than 8 meters.
Being an orientation perpendicular to Blum, that'd be over.
Oh, get out.
This is some super water, super river.
Why are you saying that they're measuring the shape of the geoid? Why are you saying that?
Because they measure it with they actually have level. A handhold level can do this. They do it with sophisticated equipment to be able to show you that.
But isn't that begging the question?
Based on the hold on, let me finish.
It's always begging the
Well,
question.
I've got a question for you, actually. Is that it?
Hold on. Hold on. Based on the perpendicular orientation to plumb, that gives you the geoid shape. Now, want me to read it again? But I think you can read it on your own. It talks about this image above shows the actual height measurements made along the banks. So they measured it. They measured it actually, and both ellipsoidal and orthometric heights are shown. That's the green line and the blue line. The river that flows northeast has an increasing ellipsoidal height. Has an increasing ellipsoidal height. Has an increasing ellipsoidal heights along its length, which means it flows uphill in an
8 meters.
This is because the ellipsoidal heights don't account for Earth's gravity field. We consider orthometric heights, which do account for variations in gravity potential. We see the heights decrease toward the mouth. As we would expect, the water flows downhill. Does that make
so
sense?
the water doesn't flow uphill then?
I've got a question, right? Hold on, Zanuck.
It flows downhill gravitationally, but not ellipsoidally.
Right, okay, so what about the distance of 500 miles? Yeah? Do you know what the actual drop is?
Of course. What do you mean? Of course, you know what the drop is.
It's 31.7 miles.
Right.
Right. So, which way is it dropping? What end of that river?
You're confusing
the
elevation.
high end or the low end?
You're confusing elevation with drop.
Okay.
You're confusing
well, there is a
elevation
drop.
with drop.
Yeah.
Elevation is what we're talking about here.
It's the curved level, isn't it?
Elevation is above
water's
sea level.
level.
Yeah,
so
exactly.
water's running.
So you're
down from the
confused. So in
hills.
other words, you're confused. Is that it? Is that what you want to? How you want to end this? You're
No, we
confused?
just don't
You
swallow
mock-
the
you
shit.
mock what you don't understand.
So is that... Sorry, Zanuck, can I just get that? He's just give us some numbers there. Like, it wasn't you that gave us the numbers. Spot on did, then.
I did
But,
give
like,
numbers, yeah.
that's 300 and something over 5...
That is the spherical drop. It's
Right.
different than
No, that's the curvature of level, isn't it? Isn't that how much level curves
Yes.
on your model?
Yes.
so that
Right, why
river's-
did Spot On have to give us that number?
Yes,
Why couldn't
Spot On.
you do it?
Because it sounds crazy.
No, it doesn't sound crazy. I already told you that
It
before.
does.
Hold on, guys. Let me read something that also sounds crazy. So if you look up geoid, and if you're not thinking about trying to win an argument, you just read it. Just read it. You say geoid. The first thing that comes up, the hypothetical shape of the Earth coinciding with the mean sea level and its imagined extension under or over land areas. That's crazy.
No, it talks about this spheroid, or the ellipsoid that is definitely under the mountains and over the base of the bottom of the ocean. It is a mean sea level. That's what it means.
Sounds pretty tame from
It's a picture.
Bible.
But it's it.
That's crazy as fuck.
So you got an understanding now of what a ellipsoid is, what a spheroid is, and what a geoid is. This is real knowledge
It's
here.
all begging the questions, Anik,
Not
though.
begging, we measure it. We actually measure it.
Oh, yeah, it's measurable.
No, it's not begging any question.
Spot on gave us it.
Let me read. Let me read to you again. Then hold on. So, although
You
a
started
surface,
off with a globe.
let me read it. Let me read.
And
Hold
then
on.
you do the maths to
So,
see.
although a chosen surface is truly the datum, it has become common practice to use the term vertical datum to mean the entire system, including the reference surface. Surveyor marks.
Reading from which book are you reading from? There's Anik.
To determine the heights
Give
relative to that
Give us
surface.
the book you're reading from.
I already see. You already see. I gave it to you already. You didn't want to go to it.
What,
This
the
is
book?
based on the NAV 88, and the what was the other standard? It goes back to 1980. The Geo 80 mapping. These are all
WGS 1984. Is that what you're talking about?
I post
None
the
of
link
this
below.
proves the spherical
If
Earth.
people do this. Here we go. I'll put. It's in the chat. There's your proof. Go read up. Once you read it, and then come back to me what you don't agree with, because right now you're just mocking what you don't understand.
I'm just gonna have a look at it. What is this? Flash.
Who's the guy that says it doesn't prove things?
I'll be back.
Oh, I can't reach it.
Who's the guy that said it doesn't prove things?
Me.
So when did science
presupposes
say
sphere,
it's
and
good?
then
So Sherlock.
comes up with math
Yo.
to make sense of observations in the context of a sphere.
Ram, Sherlock, where did science say it proves things? Because you said it like, you want to find this deep hole in science that it doesn't actually prove things. But where in science does it prove things?
Science doesn't prove anything. Science isn't in the business of proving anything. Proof only exists in mathematics.
Well, first of all, I don't think he was referring to science when he said that, but
Science doesn't prove things because that's not the business of science. Science is not about proof. Mathematics is about proof.
I think
Isn't
he
this
missed
a
his
scientific
point.
discussion?
I'll let him
Doesn't
reiterate.
science debunk something?
So science doesn't prove anything. That's your position. But you guys know that the Earth is a sphere.
It's a reasonable understanding.
Without any proof.
Mathematical representation of what we measure. We measure it.
No,
We
they
measure
have
it.
That's just
strong-
it. Just admit
strong
that it's
measure
your
it.
best
No, we
guess.
Dude,
It's your
Ram,
best guess.
can you
And
prove?
Proof only exists in mathematics.
About it. That's all
Can you
you've got.
prove to me right now that, for example, your hand has 5 fingers? Can you give me undisputable proof?
I can prove to you that 1 + 1 is 2.
I asked you, how do you prove to me that you have a hand with 5 fingers?
I'll tell you
The
how.
other guy went for a photo.
I come and I meet you, and you count how many fingers I have. That's
Really?
That's possible.
you could put
Whereas
Hold on, I
traveling
got
through
the answer
space
that was.
is not possible.
I got the answer that was satisfy Glober.
Go on.
1 × 5 = 5. There you go. Proof.
Proof only exists in mathematics.
Ooh,
That
mathematics.
was a nice little app.
So Elijah, to prove something then, to prove something then, as long as you can verify it, that's good enough for you. You don't have to verify it, but as long as you can verify it.
You see, Elijah, even if you look at it with your eyes, that is not proof. Because I can't see air, for example. That means air doesn't exist.
Right, we can go
No,
to space
I
then.
know.
No, you can
That's
go
why
to
I said.
space,
That's
so
why I
that's
said you would
definitely
have
a
to.
proof, then it's a
Well,
sphere.
Horizon's level, so stick with that.
That's why I said you would have to be able to do more than look at it. And remember, I
Well, you
said
can
you
go
would
to
see
space.
Then it's
do all
not proof
types
to
of
me.
different things to determine it.
You can go
And
to
it's
space
not
and see
proof,
the Earth.
Elijah.
So
What do you mean
that's
it's not
proof.
It's not.
Science doesn't prove things because that's not the business of science. Science is not about proof. Mathematics is about proof.
The flat Earth community is toxic.
Yeah, but what you're
Game over.
asking me to
Is your
believe is
question
very
of
different
what is question?
than me believing that someone has 5 fingers.
No, I asked you for the
Because
proof,
somebody
not the
having
belief.
5 fingers is verifiable. How is it verifiable? You can verify it by literally. Hold on. In the same way that you can meet a person, can you meet the sun and study it? No, you can't. There's the difference right there.
Yeah, you could go to the sun.
That is the difference. It's a real difference, is it not?
You could go to the sun in a spaceship, but you die. But you could go there.
Okay, who's done that?
I'm not dying.
No, you didn't say that. Elijah's evidence that we can prove it is you can. He didn't say you have to go there to prove it. He said the very fact that you can go there and verify it is good enough.
I still don't get how your visual confirmation and verification of a hand with five fingers is proof, a fucking proof in the logical, mathematical, strict sense of the word of something.
Why do you have to keep on minimalizing what I'm saying to only observation,
it's measurable.
which is actually my problem?
The reason why I asked the question is because
observation is not enough.
The reason why I asked this question
my point
is because someone said science proves things.
Science doesn't prove anything. Science isn't in the business of proving anything. Proof only exists in mathematics.
And I'm curious how they figure that.
Some of you guys are happy with just reading a meaning in a dictionary.
Okay.
So how does science prove things? Or does it even prove things in the beginning?
But science doesn't prove things because that's not what it's about.
Alright, so science is about disproving things.
Well, a scientific experiment is about disproving a hypothesis.
Alright, so if I try to disprove the flying ball Earth, am I doing science?
If you are following certain steps along the scientific method, yeah. But, I mean, it's an irrelevant question.
It proves cause and
First of
effect.
all, having five fingers is self-evident. It's like I have 5 fingers.
Self-evident.
4 fingers and a thumb.
This sort of approach is not allowed because it's
not-
self-evident
it's not
that
the
things I
same
don't say
thing.
doesn't exist.
There's a difference between being able to touch and high five someone. You don't have to look at someone to high five them. You're touching them. You're not doing any touching of the sun.
Can you touch air? According to your logic, air doesn't exist because
air.
you can't.
What do you mean, can you touch air? Yeah, you can. What do you mean? Are you saying that if I'm not walking through a fog, I'm not going to feel the water vapor on my face?
That's
that if
water
I'm driving
vapor,
through
not
a
air.
fog, it's not going to eventually... Yeah, but listen, air is made up of what?
Well, you tell me. You're the one who's gonna prove.
You can
that,
smell. You can
touch
smell
it and
gas.
therefore prove.
You can smell gas. Gas is gas, but you can smell it. Can you not? You're not smelling the sun, are you?
I'm not making assertions like you are right now in this conversation.
But I'm saying, I'm giving you examples. I'm giving you examples of how these are differences between what I can do and what you can't.
You can only present your best guess based on the evidence that you have. You will never give me any fucking proof.
That's not science. That's conceptualizing.
Rams, this is what I really don't understand, Rams, right? 'Cause if you can't find anywhere you look about science, it always tells you that science doesn't prove things.
Science doesn't prove things because that's not the business of science. Science is not about proof. Mathematics is about proof.
The flat Earth community is toxic. So I'm really confused.
So you gotta believe that.
That's not science.
That's because it's already.
That's
That's because it's
scientism.
already all pseudoscience. That's why.
Oh,
All
yeah.
pseudoscience.
Yeah.
That's why they have to say that, so that they can lump their shit in there.
Mark, listen for a moment. In a lot of schools, the university first years for freshmen, when they're stupid and are still learning, they give this idiotic definition of a scientific method and they claim that that's the whole science, so that the kids can understand it easily. So there's a guy here named Quantum Eraser, and he takes that to an extreme level, and he says that's all science is.
Yeah, I understand that.
And these guys believe him.
So
Yeah,
the propaganda,
I know Quantum Eraser, I've
propaganda
dealt with him for years.
continues.
But like, this is what makes me laugh.
propaganda
This is what
continues,
makes
and
me
they
laugh. None of
completely
these lot are involved in science.
and they
but they all
completely
know what
crush
science
any chance at critical thinking once you get to the university level. They just crush any chance of thinking.
No, I don't. But that's why I defer to people that are intelligent, more intelligent than me.
So, dude, you just said that you can... Dude, you implied you can prove things with science, and you talk of critical thinking.
So spot on level, you know better than scientists.
Without having done any.
Well, no, do you know better than scientists then?
Who, me? I haven't said anything about science.
Well, do you believe scientists? Do you think they're smarter than you in science?
Do you not agree that to do science, you
Right
need
then,
to have a
so
hypothesis?
you're in the same position as
you
me
need
then.
to
Well
do
done,
tests.
great.
So guys,
No, because what is a scientist? What does a scientist have to do with science?
Delusions.
Fuck that.
I get you.
Fuck that. No, but let me make an example. Let me make an example of why that's ridiculous. Because there are music teachers
when did I
that
say
don't
that?
know how to actually play good music.
That's
When
what you
did I
got.
say that?
That's what you got to believe, because that's what Zanuck says.
Oh, so you've got to believe the Earth's accelerating up at 9.
Well, that's what you put me in this.
What a fucking tard you are. What a tard.
Oh, that's ridiculous.
thinking
Come
the
on,
Earth-
you know that shit.
Oh, what? It's
Nice to
okay
meet
for him
ya.
to say that I've got to believe stuff, but when I do it to you, it's not alright. Yeah, that's
You didn't tell Zanuck he was wrong, did you? You just sat there while he was saying it.
I can't comment on it because I don't know what river or canal or whatever he's talking about.
But going uphill.
What,
Well, if the elevation's higher at one end than the other, then they would be uphill, wouldn't it?
Yeah. And you believe that that's fine, that water can do that.
Like I said, I can't comment on that. I can't comment
think
on
he's
that.
saying that the river at the mouth by the sea is higher than where it starts from.
Yeah.
At the hill.
Yeah, that's what he's saying.
So what do you think of that, Mark?
8 meters it goes
Like I said,
uphill
I don't know
from its source.
what he's talking about, so I can't comment on that.
Mark, he said, from its source, it goes 8 meters uphill to the sea.
I've got to tell you, I don't know what he's talking about.
He doesn't
so
want to
I
hear
can't
about
comment
it.
on
Yeah.
it.
It's alright.
Okay, Mark.
Fucking hell.
Okay,
I'm
Mark.
trying to be honest, and you fucking,
when
and I'm getting dug out for being honest. Sorry. Wow.
No, you're
Lay off of Mark. Lay off.
not. No. Sorry, Mark.
I don't care. You do it all you like. It just proves to me that you're all fucking dishonest when you say stuff like that.
Come on.
No,
You're trying to say that I should believe rivers run uphill because fucking Zanuck says it.
You said you it's alright, you've told us you don't know whether rivers can run uphill or not. So yeah, that's okay, fine.
No, it doesn't make sense to me. No,
Rivers don't run uphill.
Zanuck just said, nobody said don't say that, Zanuck.
Zanuck said something
Hold on,
else.
Red,
He
hold on,
meant
mate.
something else, genius.
Oh, right. So when Zanuck said something, he didn't actually mean that.
Yes, that's the way he fucking talks. If you want to talk to him and engage with him, that's your problem.
He's got you there.
Right, well, so everybody knows that Zanuck talks a load of shite then, did he?
No, he talks a lot of things in an overly complicated way, and his meaning can be interpreted in fucking
Rivers, the river runs uphill.
Yeah, how do you...
What's complicated about that?
Yeah, what do you think of that?
It's just
Red?
wrong, isn't it?
Not according to surveyors,
Right,
it
that
isn't.
is what's complicated with
But they don't use these words exactly as Zanuck does. They frame it in a bit more technical terms.
Was that Zanuck come back then? Zanuck, yeah, we're just discussing we're discussing your river running uphill. Nobody else believes that you actually said that, or you didn't mean it when you said it.
Rivers run uphill in the simple sense of the word.
Let Zanuck speak.
So there is the uphill water. I gave pictures. Don't make me post them again. Of the river that runs literally uphill.
If you want to listen to this stuff again and not get it, fine. Let him speak. Zanuck, go ahead. They want you to talk.
So water is level when it follows the the geoid equipotential surface. What that means is any point on that water surface, you'll find an orientation of that water which is perpendicular to level. I mean, perpendicular to the plumb line. Now,
the geoid
water,
being the theoretical.
The water's level all the time.
Level, yes, being an orientation perpendicular to the plumb line. However, on the ellipsoid, you will find that the river will actually
we want to do a test.
uphill.
Sorry to interrupt. We want to do a test. Testing 1 2 1 2.
Copy.
Loads of echo from you.
A lot of echo from me.
Yeah.
A lot of echo from us.
Fuck. Thanks, man. Out.
No worries. So, you want to hear this one?
He's gone. So now we have.
So no, hold on. Wait, I think. Let me point this out. Okay, so you're saying that it's level, which means because it's a ball, that at some point level would have to be not horizontal, but actually vertical. How is that possible with water and all this?
Because the geoid is actually curved. It's roughly a spherical shape. And they measured it.
Yeah, I just said that.
Yeah.
I just said that. I said,
Right.
How is that possible?
He's saying
Because
that water's running
mass-
uphill. That's the question.
So water has weight, and that weight is always going to be pulling it down. So any kind of concentration of a gravitational force, meaning when it's a little heavier some places than other places, it will force it to clump in certain areas, and it will make the geoid uneven. So it will not be perfectly spherical. It won't even be elliptical. It'll be a geoid by definition. There's 3 terms you have to get straight: the geoid, the spheroid, and the ellipsoid. The spheroid would be as if it's a perfect sphere. The ellipsoid is what it looks like because of its being wider at the waist.
Oh, I think I've got you.
Geoid
And
is based on
theoretical.
gravitation. The weight of the water, has weight, has force, and that geoid can be measured. And that's the picture we want to look at right there. It's an exaggeration, but it's basically what happens. The geoid only varies about 200 feet all over the Earth.
Can we go back to the uphill water, please?
There is the uphill water. I gave pictures. Don't make me post them again. Of the river that runs literally uphill from the ellipsoid. We've measured this ellipsoid. We see the shape of the Earth, and it actually is a higher point on that surface than where it starts. Yet it flows downhill. Why?
8 meters from the source, did you say?
Why? Because the geoid dictates that the gravitational force orientation is such that it actually gravitationally is going downhill, but physically going uphill.
God, that is so sweet.
Physically uphill.
Yes, physically it's
Hold
going
on.
uphill.
Catch that you said the geoid, aka the hypothetical theory, which is running your understanding of what's going on.
Measured.
It's dictating.
Elijah,
hold on,
measured.
it's dictating to you.
Professional surveyors
You just
use
said it
it.
dictates. You said
No,
it dictates.
Why? Because the geoid dictates that the gravitational force orientation is such that it actually gravitationally is going downhill, but physically going uphill.
That the water's going uphill.
They measure it.
The-
Elijah,
the-
they
the
measure
thing
it.
that you're believing
They measure
in-
it. They measure it. You can measure it yourself with a bubble level.
Oh yeah, it's
You can
measured.
actually measure it.
Water going uphill.
That's like me.
Yes.
That's like
Yes,
me
you can.
looking at a clock and then saying
No, it's
I'm
not.
about to
It's nothing
count
like
from
that.
1 to 12.
It's
Yes,
nothing
it is.
like that.
Where,
It's nothing like
where
that.
is it, Sanic? Is there a video of anyone doing this with a bubble level watching the water? Because if it physically goes uphill, that'd be fantastic. There's got to be a video of it somewhere.
Runs away from the sea.
Gravitational hill in Canada.
Yeah.
There's actually a place called the gravitational. That's an optical illusion. We're talking about a real phenomenon. A real phenomenon.
So basically, that's why it seems like the fish are
Should I give you the
swimming.
picture?
Uphill.
Elijah, do I need to post a picture again for you, bud? Come on.
I'd like to see a video of this.
The fish swim uphill because they're actually swimming downhill because of this geoid. They look like they're swimming uphill.
The river
They're swimming down.
Hey, Elijah,
It's just a little
river
joke, sorry.
actually
Yeah.
has been measured
The
to go uphill.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
They're actually going down it.
Yeah, there is no up or down. Come on.
Oh, no, of course it's not. No, because you're always on top of the ball, aren't you?
There it is. There's the river.
To be fair, Zanuck, I don't think anywhere in the paper that you're citing it actually uses
Is anyone here near that place?
Should I read it again?
Where is it? I'm not in America. Whereabouts is that in America?
It's in Canada.
Oh, it's in Canada. Who've we got?
So
in
let me
Canada?
say it again.
Earl.
It has increasing ellipsoidal heights along its length, which means it flows uphill in ellipsoidal height system. This is measured, by the way.
Oh yeah, it's measurable.
Did you read this sentence, or did you add?
Let me finish. That's because the ellipsoidal heights don't account for Earth's gravitational field. If we consider the orthometric heights, which means the geoid heights, which do account for the variations in gravity potential, we see the heights decrease toward the mouth of the river, and as we expect, the water flows downhill, gravitationally downhill, not physically downhill. It's actually going uphill, as it says. The water flows uphill in an ellipsoidal height system.
Yeah, I think that ellipsoidal height system's broken.
These are professional surveyors.
Really?
Yes, these are people that actually make sure.
You're laughing. I can hear you laughing. You know.
What?
We can hear you laughing.
I'm looking at I'm looking at
read it.
The horizontal level. You posted a picture. Oh, from Zanuck that said, here are how surveyors find level.
Yeah.
Now the funny thing about this made me think about why isn't everything covered with water then? Like perfectly to the land underneath, well, the sea. Like, because that's what this is saying, but then you have a mound of land right there to the left.
That's the land that's above the sea level.
But this is...
Hold on. 2 seconds as well, because you said that there was 500 meters. Yeah, this river
500
was
miles.
500 meters.
500 miles.
Miles, I meant, sorry. 500 miles, and you're saying there's
400 miles.
Height difference in that river.
Over 550 kilometers.
Yeah.
It's more like 350 miles.
Yeah, and as we know, if we do the Earth calculations on 500 miles...
Keep it in meters. 550...
It's
550...
31.7
Let me finish.
Drop. No, let me finish. You're always talking.
Let me finish!
Ooh. Calm down, Zanuck. Come on.
550 kilometers.
31.7
Let me
miles
finish!
drop.
Stop talking over me.
Why? Do you own this place?
Yeah,
550 miles, 550 kilometers, and we have a height.
31.7
Let me
miles.
finish! Fuck! The ellipsoidal height is 8 meters. The orthometric height goes down to 0 as it meets the mouth of the river.
It only rises 8 meters from its source.
But it drops 31.7 miles over 500 miles.
Yes. Exactly.
Right. So whilst curving 30 odd miles, it's
again level is an orientation perpendicular to the plumb, and
so
yes,
that river is running.
It will curve 31 miles over 550 kilometers.
Yeah. So I'm just saying that water is running. There's a drop of 31.7 miles with that water.
Yes.
From one place to another.
Perfectly level all the way. From
no level.
Near level. 1 meter. A 1 meter change.
A river can't be level, Zanuck.
A 1 meter drop of actual gravitational differential. The physical differential is 8 meters uphill. Think about that. Yes. See why you're
thought about it, right?
You just got to believe him, guys.
No, you got to think.
I thought about it, and I think you're mad.
Learn something. Understand the basic concepts, Rams.
Thanks, Zanuck.
Stop questioning what you don't understand. Stop questioning what you don't understand. Stop questioning what you don't understand.
Hey, time out. Sorry, we're gonna ruin your day again. Radio check.
Yeah.
Mic check.
Yeah, copy that.
You're good.
Loads cleaner.
No echo.
Very good.
Seems fine.
No echo.
Okay, we're gonna try something here. I want you guys to tell me if you can hear this.
Learn the fucking scientific method or get the fuck out of here. Not you, Nathan. I'm talking to everyone. Not you, Nathan. I've been doing this for 4 fucking years. If you didn't fucking get it by now, get the fuck out of here. Not you, Nathan. You're part of the problem. Not you, Nathan. Fuck your shit. Not you, Nathan.
That's a
Sick of
problem.
this
Okay,
shit.
sorry to interrupt the argument, and I think I can end this for today. So appreciate it, man. Thanks for putting up with us.
It's a shame you're not involved in this conversation.
Yeah, I got bigger issues.
Yeah.
When you pop in, I was like, "Oh,
good luck, man.
Let him get that hypothesis going with that."
Yeah, I got a hypothesis with voice meter banana. I'm gonna rip its fucking guts out. Well, later, man.
Later.
No mercy.
Later, guys.
Kill.
He's a character, isn't he?
That he is.
I think he might be trying to get OBS working through Discord.
I'd like to go on a canoe on that river.
Oh, yeah. Sounds fun, doesn't it? I bet it's hard work. I bet the canoe, that's where they go, canoeists go training. It's always uphill.
It just keeps coming at you. Like you don't actually go and...
It'd be quite good training that, because you could get to the sea and then you could go downhill all the way back to the beginning of the river, couldn't you? Get to the sea and float back.
And all the people on the side of the walkways be looking, going, "How you doing that?" You just go, "It's an ellipsoid."
Geoid. Do you not know about geoids? God.
I've got the papers here, mate. I'd actually just send them here.
That's good. I should write that down as a bit.
Zanic's uphill river. That's going to be lasting for ages. He's got to get more information about that now. I'll have to find some more rivers that flow uphill.
Every that's ever taken a surveying class knows this, except for you.
What, the rivers flow uphill to the sea?
Class, that's the problem.
Yeah, you gotta learn this stuff. It's actually knowledge.
Yeah.
I mean, you can learn it. You can if you understand it, you'll be able to go out and do your own testing. You can get a theodolite. You can get a bunch of plumb bobs. And you go out and knock yourself out and learn about it.
I reckon, what about my wall that I was talking about earlier? Like, if you had a wall that was 10 miles long and you got a 4 foot level and put a line underneath the bottom of it and then moved it along 4 foot and keep going, and you run your eye in it and it's absolutely bang on level, would that be bent?
I don't know what you said. What did you say?
Well, if you got a wall that's 10 miles long.
A wall?
Yeah, and you got your 4 foot level. Literally a 4 foot level, you know what I mean? Like carpenters or bricklayers.
Okay.
You move that level from point to point every 4 foot in a nice straight line. That wall, when you get your eye on it, it looks absolutely perfect.
Yep.
Yeah. And then you go and check it with another level, and you put like you go along.
What do you mean?
with
Hold on. What do you mean another level? So far,
like
gotcha. So I've got a level, and I'm going for every 4 feet. I'm measuring with my level and a plumb bob, and I'm measuring level every.
With the plumb bob.
No, just a level on the top of the wall, and it's
top of the wall. Every 4 feet, I got that level on the wall, and it looks perfectly level.
Yeah, and it's going. I run my eye along it, and it's really spot on. Yeah,
perfect
and
level.
I go and get a level, like one that you look through.
And at the end of 1 mile, it'll drop 8 inches.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
That's all I needed to know.
This is what Brian Mullen proposed, isn't it?
Yeah, and that's why we've already built that. So I've already posted the picture of the straightest and flattest object in the universe, and that is basically the force line. That is the force line, basically in real life. They've already done. See, a lot of the stuff they've already done, you guys just aren't aware of it.
Yeah, we've heard about it. Is it? What's this? Have you put it up? Have you? Where's this picture?
Yeah, there we go.
Is this?
So this is the object.
Where there's like a meter.
Inside this object is a tube, a vacuum tube, has a tolerance of 20 thousandths of an inch over 2 miles. Now, one end, so in the middle, is 8 inches lower than the middle, and the other end is 8 inches lower than the middle. If it was level, but it's not.
And at the end of this 4 kilometers, actually was an excellent demonstration of the curvature of the Earth, because as you can see, this one is next to a flowing stream, which we all know will be level. And at the end of this 4 kilometers stretch of tube, there was 1.5 meters of curve that had dropped away, matching Globe predictions.
Right, is this the one where the balls roll to the middle?
So this is where the ball would roll to the middle, yes.
Is it lower in the middle or higher?
It's perfectly flat. But
balls rolling.
But compared to the geoid or even the ellipsoid, it actually has the plumb lines on the end are pointing inward, meaning it's not level. So it's not level; it's flat.
Yeah. Okay. Wow. Yeah.
Now this is reality for you.
Carry on with that one.
I've been there. I've talked to people that built this place. It's the way it is. You don't believe it because you're confused. That's okay.
Say that again. Which way are the verticals pointing, Danik?
The vertical in the middle is straight down, plumb line straight down.
Yeah, at the ends.
The ends have angled plumb bobs.
Yeah. Which way to the angle?
Because one side from the middle is 8 inches lower than the other side.
Right, but then how does the ball roll towards the middle?
That's why.
Why?
What?
Because the plumb lines are pointed inward.
Plumb lines are pointing inwards. You just said they were pointing outwards. Which inwards at the top or inwards at the bottom?
Wait.
Because the plumb bobs are going inward.
Let's take all of the smart malarkey out of this. And let's just talk like a regular.
Level. The ends are not level.
No, but
yeah, but they're not. They're not.
No.
Let's straight, but the ends are not level.
Because hold on. Here's the thing. If you try to roll a ball up a hill, it's not gonna stop in the middle of the hill where the other side is starting to go down.
And that's where this is so much. So
See what I mean?
Actually, we'll do that. You will roll it from one end, roll to the middle, and then it'll stop in the middle. It'll overshoot and come back and eventually oscillate, and you end up in the middle. Because the middle is plumb line.
As though it's concave, right?
Let me finish. The middle the orientation of the middle is plumb line perpendicular. Right?
Yeah, but it'd have to be concaved, wouldn't it? This shape for the balls to do what you claimed.
Within 20,000 of an inch inside.
Off the ends.
Straight.
The middle will be higher than the outsides.
20 thousandths of an inch tolerance from end to end. 20 thousandths, perfectly straight. Yet it doesn't drop 8 inches from the middle of the end, or you would have a curved shape, which you don't. It doesn't drop 8 inches. It's perfectly flat.
Right. Okay.
So the ends have a plumb. Let me finish. The ends have a plumb bob that is slightly angled by about 0.04 degrees. So it basically rolls to the center.
No, wait. Let's go back to that, to the end bit, the plumb bobs. Where you say point inwards, which way is pointing inwards? Underneath or on top?
Toward the center of the structure, because the object below them.
Yeah. On the top or on the bottom?
Either way.
What?
Either way.
What do you mean either way? Like one shape is convex and the other one is concave.
Both flat as a pancake. They're both straight as an arrow. They have to be straight.
So then the verticals are 90 degrees then?
They enclose the straightest object in the universe.
In the universe?
Yeah. As far as we know, this is the straightest object in the universe.
It's super straight.
How long is it?
2 miles long, kept within 20 thousandths of an inch, like a spark plug gap of accuracy of straightness.
Yeah. Right, but so the verticals at the ends, I'm trying to get, like you say it's...
Now if you hang a plumb bob at the ends, they point inward by 0.05 degrees.
Underneath.
Hanging from the object. That's straight.
Yes, so they point inwards underneath. So imagine they go in like a straight line above. Yeah, they would be pointing like to your supposed center of mass.
You put the plumb bob on the end and it points inward.
Right, okay. So how does the ball roll towards the center?
You know why? Because if it was not straight, it'd be curved, and then the ends would be perpendicular to level. You know why? Because if it was not straight, it'd be curved, and then the ends would be perpendicular to level. See, the level would be orientation.
In the
middle.
I don't know what you're talking
Why
about.
is this so hard to imagine?
Can we get a
Not that
consensus?
complicated. A fifth grader.
Hold on. Can we get a consensus?
Speaking a different
Can
language.
we get a consensus from the rest of the room? Other than I obviously, based on his explanation, I'm like, okay, if it's going to the middle, then it has to be concave.
Yes.
Apparently,
agreed.
The horizontal level is thinking the same thing that I'm thinking. Is there anyone who agrees with Zanuck or agrees with us, and why? Let's just do a quick survey.
Not to the point, because it's appeal to popularity, fella.
No, it's checking who's understanding.
Yeah, but I still.
Yeah, you can check, no problem.
It's not convex, it's straight. The ends have a plumb bob that curves or points inward because it is straight, and the object beneath him is curved.
Are they metal balls then, and the magnets in the middle?
So it is curved. Why do you gotta talk over me? Hey!
Well, yeah, because I'm just trying to get some understanding. You're saying that it's straight, the straightest thing in the galaxy.
Yes.
And then you're saying there's plumb bobs at each end, and they're coming like inwards as they go further.
Correct.
Back.
Because the
That's what you're
surface
saying. And the hole is sitting in the middle.
Yeah, well, you finish your thought or not?
No, he hadn't finished.
Because
I haven't
the geoid
finished.
God damn it! Because the geoid. Let me talk.
No, he hadn't finished.
Stop interrupting me.
Well, no, he hadn't finished.
Zanuck, you've spoken more than anyone.
The geoid underneath is curved. The geoid, the gravitational orientation, lines of down are curved.
You've got to start with the sphere, everybody. You've got to start with that.
You don't.
Hey,
You
so
don't.
this level,
You
this
don't.
level
It shows
line,
the
Zanuck,
sphere. Why else would the plumb bobs be pointed inwards?
Zanuck,
Why else?
Please answer.
Don't you understand?
Yeah,
Seriously,
I understand what you're
it's a
saying.
straight
but I'm not
object.
understanding it.
The ends plumb bobs go inward. The middle is straight down. It's not convex. It's straight by 20 thousandths of an inch. Do you have to say this a fucking thousand times?
Yeah, is it level though?
Is it level? No, it's not level.
Oh,
it's not level. I mean,
it's straight around the curve.
It's
Isn't
not level at the ends.
Yeah, it's the straightest thing in the universe. It's just straight around the geoid.
Straight. It's straight. It's flat. Meaning it is the shortest distance between 2 points.
So yeah, fight the flat Earth straight.
That is a line.
Yep.
It is a tangent. It is a tangent to the Earth.
It's a straight curve line.
What part of this don't you understand?
It's a straight line, yeah?
And it's curved.
Straight line, yes. By accuracy of 20 thousandths of an inch.
That's about it.
Accuracy of 20 thousandths of an inch.
Why is the ball in the
So
middle?
it's a curved straight line.
Yeah.
No, it's a straight line with no curve in it.
It's a straight line with no curve.
Yeah,
It follows the
straight
geoid
as
of a
Luther
thing,
Vandross.
yet balls
It doesn't
roll
follow the
opposite
geoid.
to the
It does not follow
thing.
the geoid. It follows a straight
It's
path.
as straight as Luther Vandross.
Straight. That's funny. Straight as an arrow. Flat. No variations. By 20 thousandths of an inch. Don't make me give that friggin' spec again.
Fair
20
play to you,
thousandths of an
Zanuck.
inch
I mean,
straightness.
like, you're obviously
Perfectly
clued
straight,
up on this.
but it is not level at the ends. The plumb bobs point inward. They point inward.
All right, Zanuck.
Because the geoid underneath is curved. The gravitational lines are angled. That's why the ends.
Fair enough. How
have
far
plumb
have they,
bobs
how
that
far have
point
they dropped the
inward.
lines down to figure that out?
Learn something.
How far did they drop the plumb bobs to find out the distance that's, at the
You can
bottom?
use a bubble level. You can use whatever you want. You'll see the measurement is accurate.
Hold on. You said there's a plumb bob at each end, yeah?
No, you put a plumb bob at each end. Yes, they've
Right,
done
okay,
that.
and how far down do they go?
Yeah, how far?
Who cares?
How
It
far
doesn't
down?
align
Hold on,
with the
Redux.
plumb bob.
Hold on,
Well,
hold on,
They have
Redux.
they have a very accurate leveling tool that shows the degrees that they are off, and they're off
How
by
far down?
a few feet.
Oh, is that it?
Yeah.
So they've gone 2 miles laterally, level,
Yes.
mate. And then they've gone 2 foot, measured that, and said, "Oh, there's a bit of an angle there."
To measure the angle.
It's a bit of an angle there, and
Plumb bobs measure angle very accurately. Plumb bobs measure angle very accurately. Plumb bobs measure angle very accurately.
put a ball on that, and
You know this? You can hang a
rolls
plumb bob.
in.
There's a little point. Hold on. You can have a plumb
The builders are going, yeah, that's leveled, yeah. Oh, within a thousandth of an inch.
Yeah,
I will
that's the
mute
flattest thing in this galaxy, mate.
Watch these balls roll.
People always mock what they don't understand. Always.
Oh God.
Does anybody on the other side or anybody understand what I've said besides these 3
Yes.
clowns?
Who's that?
I don't think it's that they don't understand. I think that they're
a
trying
very
to understand.
long and, in my opinion,
I did ask who agreed with Zanuck, but I didn't want that explanation to roll on by and then him ask that question, because I need it to be in your mind that the actual thing. Hold on. The actual thing that would actually be happening. He's saying the ball would go to the middle of this thing.
Yes.
Now, anyone who's a rationally thinking person, you know the only reason that that's going to happen is because you have this thing curving upwards on both sides. It's not going to be curving the opposite way, and then the ball is going to roll to the middle. That would never happen except for in this explanation.
So
this
you
is
can't wrap
come
your head
on.
around the concept. You argue it. So you can't understand the concept.
I'm not going to wrap my head around that. That's the thing. I'm not going to wrap my head around that when I know that that's not the case. That's like saying that's like you telling me somebody died and then their body literally floated up into the air until you couldn't see it anymore. And then you give me a damn good explanation. And then you give me a damn good explanation on the back of a napkin. And then you say, listen, based on this explanation, it makes sense.
Elijah, we have a tangent. You know what that word means?
I wasn't finished. That's why I got louder and louder.
So we have a tangent. And it's on top of it means we're on top of a sphere. And the tangent is where it touches, right? At that point, we have a geoid, orthometric relationship, which is a perpendicular to the plumb bob, right? In orientation, perpendicular to the plumb bob. Anywhere else on that, you will see an angle of that plumb bob inward because beneath it is a curved gravitational field. That's why.
In your model, you're right. Okay.
So as long as
that's
you
in your model.
Hey, as long as we understand the model, that's fine. But that's what we see in reality as well.
You said they only measured 2
That's where I disagree.
You don't think they've measured that? You don't think
reality
that object measured that I'm telling you?
I think you've probably got your story
That's what
wrong.
I'm saying. Yeah, I understand it too, because the way you're describing it, the way you're describing it is hitting the rest of us.
Go find a surveyor. Go ahead. I challenge you. Bring him back here, and I'll chat with him. And they will agree with me on every.
But the way you're explaining it is resonating to all of us the exact same way. Because the obvious question would be what I just said.
No, you said
and then
you're
like all you do is re-explain what you've already explained. That doesn't change the fact that a ball going to the middle of this thing is fucking nuts.
Yeah, no, because
based on your explanation.
Because
even you can re-explain it, but I'm still gonna be like, okay, but how does that make sense?
The fundamental difference in our perspectives is that we just refuse to presuppose the ball.
You don't have to. The plumb line is altered as you leave the center to the ends, and it's most dramatic.
That doesn't happen. Verticals are parallel.
Hey, don't interrupt me. The plumb line varies as you leave the center, Elijah, and as you get to the ends, it is the most dramatic. Is the most angled at the ends. That is why
it would go down though, wouldn't it, on the ends?
Stop.
So why is the ball in the middle?
To have a gravitational equilibrium, and that gravitational equilibrium for the ball will be at the center and only at the center.
I got to say, can I just say, I've really enjoyed having a chat tonight. I hope I haven't offended anyone by my raised voice. I'm not used to this sort of thing, so but no, thanks for taking part, everyone.
Good on you, bro.
And you. You didn't raise your voice loud enough to upset me. I don't know about.
Oh yeah.
Zanuck might get offended.
No, when you talk over people, it's just rude.
Yeah, you do it all the time.
Yeah,
No, I don't. I try to stop whenever someone's
talking over people is rude.
Sorry, Redux, if I talked over you. Sorry, Zanuck, if I talked over you. Funk, and anyone else.
Okay, yeah.
What are you talking about? You practically spoke to him.
Like Funk said before that he understood what Zanuck was saying, but can you have a go at explaining it then, Funk? Because Zanuck doesn't seem to be able to get it across to us what he's talking about. We
can explain it to
we
you
can't
very
understand how he has it, the ends pointing inwards and then have the balls rolling towards the center. Can you
What
explain that,
Zanuck
please?
is talking about is they dug a very straight line. That's it. That's all what he's trying to get to in his gigantic explanation.
But one seems to
They
contradict
dug a
the other.
very
Do you not
straight
see that? Do you not see the way the plumb line contradict what the balls are doing? And then that also contradicts when he says it's dead flat.
I'm sure you can also prove it's wrong by building a particle accelerator that is better, but...
What? No, I don't think he's talking about the particle accelerator bit. He's just talking about it being... He says it's level, or like it's the flattest, straightest thing, but then the ends have verticals that point together, which would seem like that as a curve. Would necessitate a curve. And
sorry.
Balls move to the center. That's 3 different things that are happening. He's taking convex, concave, and level. He's got all 3.
And water going
It's not that difficult to understand, Bev. You have a straight object, and it's basically a tangent.
That's amazing, is what it is.
It's a straight object that curves both ways.
It doesn't curve. It's straight as an arrow. It's basically a tangent.
God, please.
It is a tangent on a curved surface, both physically and gravitationally. It has equal potential. The equal potential points on the surface beneath you is curved, but the plumb lines are angled inward at the ends. That's not convex, not concave. It's straight as an arrow. What's beneath it gravitationally is angled.
Yeah. Are the balls still rolling towards the center?
The ball rolls to the center, yes.
Right, brilliant. So that once again, you've just covered all 3 options there.
No, because that's part of the demonstration they do. They go to the ends and they put the ball on the ground and it rolls like 10 or 15 feet. Like it has as much inclination gravitationally as the Nile River.
So no. So the only thing that has real world interaction is the fact that you see the ball stop in the middle. So you couldn't come up with a better explanation than it's all 3.
They have a plumb line that is angled inward at the ends.
I hear all of that.
There's no explanation.
But what I'm saying, how about focusing on what the ball does? You like to focus on physics. Well, the ball goes to the middle. Why would it do that? Like you have some other theoretical explanation as to why.
The lines of equal potential, equal potential are oriented inward. They're all inward until it gets to the center where it's straight down. The orientation at the center is a tangent, and it is perpendicular to plumb. That orientation is
the plumb line at the end. Is the plumb line at the end perfectly square?
No, it's angled inward.
So, but it's not square with the object.
No, it's angled
in terms of its direction.
It's angled inward. Yes.
You understand the question I'm asking about whether it's square?
Yes,
with
it's not square.
The object with the line.
It's angled inward. The plumb line is inward. It's not perpendicular to the. It's not perpendicular to the object, which is the straightest object in the universe that we know, within 20 thousandths of an inch.
I reckon they had some dodgy builders in, mate.
Yeah.
No. The structure itself is built around it. It also is reasonably.
They've had someone like Zanuck in, haven't they?
But you can do the same
It's like,
test.
are you sure you've done this right? Oh, yeah. Yeah.
No,
Oh, yeah. Yeah.
Yes.
You don't really seem to know what you're doing. Oh, yeah. Okay. Yeah. No, loads.
What do you mean? I got
Again,
a.
people always mock what they don't
Yeah, the equipotential of the plumb bob and
Yeah.
verticals and the, you
People
know,
always
yeah.
mock, they don't
Have you
understand.
seen how many
Oh.
pens I've got in my top pocket?
Yeah. Look, I'm wearing my white coat today. Clipboard.
Oh, yeah, you and Riley, right? With the white coat? Or Sleeping Warrior, or whether
Could you imagine?
Zanuck
He
builders.
says all of this. Everybody's looking at him over the years. Oh, that babbling fool! What is he talking about? Then he builds the Hadron Collider and shit. It's like,
Who's that?
that's what I'm
Who's
saying.
the Hadron
That was a
Collider?
bad joke.
Yeah. Riley's going to build a Hadron Collider.
Make sure it's straight, convex, concaved surface that when you're
Straight and
finished.
narrow. No, there's no shape differential. There's just basically straight. Straight line, flat, straight, tangent.
No. See, like, you don't
Built
seem
to
to
be a
understand that
tangent.
you're...
It has to be. It's a tangent.
It has to be.
It has to be.
Yeah, there you go. Well done.
That's it.
Well, it has to be. You're
Yeah, good. Of course it has to be.
It's a
It's got to
particle
fit round that
accelerator. What are you talking
model,
about?
hasn't it?
Can't be any variance at all. And it's in a vacuum, by the way, too.
It's in a vacuum.
Yeah, they have the tube has a vacuum too.
Inside it. Like, it's not in a vacuum, is it?
No, inside is a vacuum. Inside the tube is a vacuum.
Oh, so that's like the longest vacuum they've got.
Yes.
Sweet.
And you should see the steps they take to construct those tubes to keep that thing to be nice and straight.
Does stuff in the vacuum go towards the
Why do you
centre?
talk over every time I'm talking? Why?
Because you're always talking.
No, I'm making a point that in order to keep the thing straight within 2 miles, man, the machining they had to do was unbelievable.
And that's why the ball sits in the middle. Because it's absolutely spot on level.
Yeah.
Perfect. Not
Rolls-
level.
rolls to
not
the middle.
level. It's not level. In the middle, it's level.
Straight.
Nowhere else.
It's straight, but just level in the middle.
400s.
It's the straightest thing in the universe. Just the middle of it is level.
And the yeah. The ball stays in the middle, yeah?
Yeah, the ball rolls towards the middle from the outside. But the
So if you put a
verticals...
4 foot level on the end, it would not show level.
That's what he's saying, yeah. But it's the straightest thing in the universe. But just just the centre bit.
Place, I'm taking a 4 foot level and I'm putting it on the end. And if it ain't level, well, honestly, get the builders back. Zanuck, do you reckon if you put a 4 foot level on the bit near the end, would it show level?
And what kind of books would you have to bring with you to your job to keep it?
Prop the end up with your books.
And then dragged it all the way to the middle and all the way, and then filmed the bubble from up above. You'd see the bubble go from left to right.
Yes, that's what happens.
But it's straight.
If you put the level on that structure and moved it down 1 mile from the center, you would see the bubble move from the center to one of the ends.
But it's the straightest thing in the universe, right?
How much did it cost to build?
Pardon
I'd
me?
like to just... Sorry.
How much did it cost to build?
Yeah.
I would guess a lot.
Yeah, in 1960 dollars, 1960.
What, like tens of millions?
I think it was over $1 billion in today's dollars.
Right. Okay, I wish they'd have just literally got a hose pipe, a real long one, got a water level, like filled up with water, and done it to that. That'd have been spot on, mate. That's all they had to do, and it would have cost.
Yeah, you tell them, man. Build a better accelerator.
And well,
can I quid on hose pipe and never sorted it?
Can I just get this confirmed, right? This is the straightest thing in the universe, right, Zanuck?
Yes.
And
Yes.
if you, like you say, if you put a level on one end and move it all the way to the other end, the bubble would move from one side cross to the middle. It would be at the middle, in the middle, and then it'd move to the other side at the other end, yeah?
Yes.
Whilst
exactly
being
right.
the
Finally
straightest thing
got it.
in
yes.
the universe.
Yes.
Right.
You finally got it.
You know how to make a spirit level longer?
Remember,
Do you,
level is an
do
orientation.
you know how to make a spirit level
Orientation
longer,
Well,
Zanuck? You would use it on a straight edge, wouldn't you?
Right.
And that would extend the level, wouldn't it?
Now let's say you made this. Let's say you put
So the
bubble.
bubble wouldn't move, would it, Zanuck, if it was
Hold on,
straight?
Let me answer the question. Let's stop for a second.
I ain't having him do any of my building work.
Let me speak. Let me speak. If you made a level the same size as this structure, the bubbles in all sections would be going from the center to the outer portions of it as you work your way to the end.
I got one bubble.
So that
mate, on the
particular
level.
spirit level would not work very well, would it?
It would if you had a massive straight, if you had a 2 mile straight edge, if you had the straightest thing in the universe as your straight edge, then yeah.
You'd say, why are the ends not level in the center?
No, you wouldn't. You'd go,
Yes, you would.
we'll just get that straight edge.
I'm here today. To tell you that
That's a
that
good
is
question.
wrong.
Hey,
Sorry.
Zanuck, it's a good question. So you've got 2 mile level, and there's a bubble in the middle. Which way would it show it falling?
Where would the bubbles be at the ends?
No, like there's a bubble in the
The
middle.
bubble's in the middle. The bubble's right in the middle, in the center of this thing.
Yeah.
Right, so it'll be straight then.
And you've got a massive
No,
straight
it's
edge,
center.
the straightest thing in the universe.
The outer bubble. Hold on. The outer bubbles would not be in the center.
What do you mean outer bubble? There's only one bubble.
If you had bubbles.
No,
Yeah, you put vertical bubbles on the other ends, don't
Why
you?
you ask me a question? Let me finish. Fuck. Why do you guys?
There's only one bubble. That's the
so
thing.
stupid. It's ridiculous.
Why?
It's just annoying.
You want to see if it's
Fucking
level? No, you want to twist
Fucking
it.
annoying.
So that
You ask me a question, and I'm trying to respond. You talk over me.
Straight level.
Let me answer. Just don't interrupt me.
No, I don't want to hear your shit.
You asked me a question. I'm telling you the answer.
I said one bubble.
And yes, the bubble in the center would be right to the center. You're right.
Right, thank you.
The bubbles on the end, however, would not be in the center.
My level hasn't got bubbles on the end.
Most bubbles do. Most
No,
bubble
they
levels
don't. They're for the perpendicular, not the horizontal.
Yeah. They would not be level.
Well, no, because they're for the horizontal.
No,
Sorry, perpendicular.
the outside ones would not be in the center either. They would not be perpendicular. Because remember, the outside ones, like you said, are perpendicular. Einstein, they would be up or down in the bubble level as well.
Well, there's only one bubble in the level, so.
I like the way your straight thing isn't really straight.
It's straight as an arrow.
I like that. Well, it can't be. It's got to be curved. If the bubble is different on the ends from the center, then yeah, it's curved. That, Zanuck.
Again, if you had bubbles at the end of the level would show that it wasn't level at the end after all, would it be? No. The center's level, the ends would not be level because...
Well, it's not straight then, Zanuck. Get the builders back. They've got it drooping.
Hold on. Why do you put emphasis on...
Oh, who's that?
Elijah, mate.
Yeah, dude, you sound like you get your hand over your mic.
Pillow.
Wow.
Sorry.
Sort of like Charlie
Let's
Brown.
say, if you have to... Right. I can't. I can't.
The bubble on the ends would be pointed toward the outside, where the bubble in the middle would be in the middle. That's how
we
a
bend
straight
then, yeah?
edge would look. Why do you gotta speak right in the middle of a sentence? I don't understand it.
Because I was just saying it's going to be a bend level.
No, I mean, I told you. I had a short little sentence, and you still gotta fucking talk over me.
Where would the bubble be on the outside? Would it be
the outside.
further towards the outside?
Yes,
On the outsides?
on the outsides.
The bubble would be on the same side that it's on.
What does that even mean?
Well, I'm just imagining a spirit level, like, and so where's the bubble within this spirit level? Is it on the side where it's going to?
Oh, we're getting the finer details now.
Well, I know how spirit levels work, as do you. So, Zanik, where's the bubble? Further towards the outside?
Not in the center.
What? So on the right hand side, you go to the right hand side. Where would the bubble be? On the right hand side of the line or the left?
It would be on the left.
Who said that? Zanik.
I told you.
I
on the
said
outside.
that.
No, Zanik says it's on the right. If it goes
No,
to
I
the
said it's
right,
on
the bubble goes to the right.
The outside. The outside of the level.
Yeah. So if you're on the right, then the bubble's on the right, and you move all the way to the left, and the bubble goes to the centre, and then goes all the way over to the left, right?
Correct.
Yeah. Thank you. That's why the balls are rolling to the centre, mate.
Right.
It's concave.
Isn't it funny how it does that with a perfectly straight outward?
Zanik, that's the wrong fucking bend, mate.
No, it's not.
It is.
Yeah, it is. It's the wrong bend.
You just proved to us that you haven't got a fucking clue.
How
Thank you.
Wrong?
The bubble.
How's it wrong?
If the bubble's on the right hand side of the level, it means it's leaning to the left. Yeah.
What's that?
The bubble goes to the high spot, you pillock.
It goes to the high side. If it's on the left, it's pointing down to the center, to the right. The bubble. You're looking at something. It's on the left. The bubble's up. That means it's pointing downward. That means that your slope is to the center, and that's what you'd see. So I'm not wrong. You guys are so stupid.
Yeah, right. It's us. Yeah, obviously us.
Correct me, and you even got it backward.
Have we not got any ballers into
You said it was wrong.
It's coming back Zanik up here. I'm surprised. Not surprised.
Hold on. Let me point out, Zanik, that the bubble is going to be up. Whether it's not going to be at the outsides at the tip if it's pointing downward.
What?
Yeah, thanks.
It would only do that. It would only do that if it was pointing up. If the ends were pointing upward. That's when the air would be up, not down.
That one.
If it's down,
Zanik,
I don't even know.
The wrong way.
The plumb bob is pointing inward. That means the bubble is pointing outward. What's so hard to understand?
Yeah, talk to him unorthodox.
Yeah.
Hey,
put him right. He's making you look stupid, man.
Listen,
Come on.
no.
We've been saying all along it's concave, and he said no.
Listen. So for the plumb bob to point inward, the bubble has to be outward. Why can't you understand basic concepts?
So you're saying that the where the ball sits in the middle is lower than the left and the right?
What do you mean?
You're
lower?
letting him have gravity as a fixed position directly
Geoid.
below the
Remember,
center
gravitational
of
line.
that.
There's a
of that,
plumb bob on the outside.
construction.
No, we're just proving that Zanik hasn't got a clue what he's talking about.
Go inward. The bubble on the outside is to the outside.
Well, so it's leaning inwards.
No, it's straight as an arrow.
Gets better.
But the plumb bob goes inward.
But that's the problem. If I have
plumb bob goes inward.
Hold on. If I have a tank with the top and I fill it up with water, except for like a bubble in each section. There's 3 sections, right? And I have different levels of water, right? The bubbles are all going to be at the top. So for you to regardless of the whatever orientation of this thing that you're trying to say is straight, essentially the bubbles would rise to the top, to the level. It doesn't even have anything to do with whether.
If you have a level, and at the end you had that level, if you measured it, the bubble would be to the outside, even though this object is straight as an arrow. That's because the plumb bob would be pointing inward. That's how it works. They're inverse relationship. The plumb bob goes inward, the level bubble goes outward. That's how it works.
It's gravity at a fixed position.
That's not how it works.
Yes, that is how it works. Gravity is the plumb bob. Again, I've said this probably 40 times already. The plumb bob goes inward.
You don't know what you're talking about.
Why?
I don't think it's that the guys here don't
You said it'd be reversed. You even agreed with him. That's wrong.
There you
also.
go. Have a look.
Yeah, because you said
Just done a picture of my level with the bubble on the outside. Can you see what angle that level is at to have the bubble on the outside, Zanik? This would be on the right, wouldn't it?
To the right. To the right.
Yeah. So can you see what angle that's at?
Yes, that would be the right-hand side of this structure.
So, like, yeah, pointing inwards, pointing downwards.
No, outwards. The bulb is going outward.
Yeah, so it goes down towards the middle.
It goes down toward the middle. Yes.
What? Oh, this changes everything.
On both ends. It's concave. This is what we've been saying all along. This is why the balls roll to the centre.
Everybody heard
So
it.
why? So you're saying that it runs down to the middle then, basically?
Yes. Thank you. Finally. Really? The
Well,
ball
it just
rolls
doesn't
to the
make
middle
sense.
because that's what it looks like gravitationally, like the St. Lawrence River.
What?
Same thing.
No, Xanax, but the
This
thing
is gravity at the center of a
your
ball.
explanation.
It's the wrong way.
No, it's not the wrong way.
It is. It's concave, you muppet.
No, it's not concave because it's flat and straight.
It is the
moves
right
because
way
the
on
plumb
the
line-
sphere model.
The plumb line moves.
How can
Well,
it be flat and
magically,
straight if
the
the
plumb
level-
line moves at the ends. Why
How
does
can
the
it
plumb
be-
line correspond? That's a level I just hit. The plumb line moves inward at the ends of the structure. Inward.
Were you holding a level then, Zanik? Were you?
I have a level right here in my hand.
Is it better than mine?
No, it's not as nice as yours. Mine is not green. Mine is clear.
This is what you got. Oh, I see.
Zanik is right, presupposing a ball and gravity at the center.
Yeah, but why is it concave?
Conceptually.
But Rams, we measure it. We actually have surveyors that can take plumb bobs and do this measurement all over the earth. They have thousands of millions of.
They can't measure a concave surface all
not
over the earth,
concave.
can they, you
It's
muppet?
flat. I told you, it's the straightest object in the universe that we know of.
If it's flat, yeah, and level, then there shouldn't be any turn on the
It's
bubble.
not level
So why did they build it unlevel?
because it's straight.
Well, why didn't they just do it level?
Because it'd be curved if it was
Yeah,
level.
yeah, you see, he doesn't.
Oh,
I see. Yeah.
Yes.
I got you now.
So,
object
so
in the universe.
straight
Kept
means
within 20 thousandths of an inch is level.
you
It's not level,
have to
it's
have
straight.
a bendy level in order to tell it straight. Man,
Yes,
come on,
it's
spot
bendy
on.
level, right? It's bendy
I
level.
get it now. I get what you're
Curves
saying.
are level. Yes, the
You
curve
might
is
want-
level. Yes, they do.
Yeah, if
Otherwise,
you're doing
big
a
buildings
drainage
and the
run-
balls roll to the center, and it doesn't
If
happen.
you're
That
doing
way.
a drainage run, yeah, for like a mile, and you're running a main drain, that's all you got to do is keep it level.
No, no,
And curve.
no,
It'll bend downwards.
no. You don't have to keep it. You don't keep it level. You want to have a little bit of inclination. Gravitationally, the geoid tells you what you have to do. Again, I posted the book. Try to take the test. See if you can
Like
pass
that
it.
8 inches of level that you were talking about earlier, Zanik, yeah?
See if you- yeah,
That
8
8 inches of curve
It's
within the
basically about
level
8 inches of curve
over that
equivalence.
mile.
8 inches of equivalence. It's basically the same.
Right, so if you're running a drain,
I was finishing a sentence.
yeah, but if you're running a drain though from one side, how do you know which way it's going down?
Stop! I'm not
Xanax.
finished.
Zanik, stop blowing out my headphones.
He's got to stop. He's
Seriously.
got to stop interrupting me.
Stop shouting then.
Stop. I don't like saying things twice.
No, nor do we.
You say it about 8 times. Fucking hell, what are you talking about?
And should we all just have 10 seconds to this?
Just think about this
About what's
straight line that isn't level. That's how we know it's straight.
So we have engineers that actually measure this. Surveyors that measure and see that at the end of straight objects or straight floors in large buildings,
Yeah.
that they will be level on both ends, yet they will be curved. What they're facing beneath them is curved.
In construction, Zanik.
That's how they measure straight.
We put things in with
No, they do. They know the curvature of the earth. They can measure this kind of stuff. This is surveyors do. They want water to not pile up in areas where they don't want it to pile up.
Pile up.
If you take that test, you'll see that very long straight objects are not level end to end. That's just fundamental knowledge of surveying.
No, it's not.
It's called it. Yes, it is. Well, they have.
No, it ain't.
My God, yes, it is. Books are written. You never built a big building before.
Have I?
Yeah.
No, not a big.
I suppose you have.
How do you know?
My house has. No, I'm saying surveyors have.
Surveyors don't build houses, Zanuck.
Surveyors build a house.
Surveyors don't build houses, Zanuck.
No, they need to know where things will flood, and they measure these things.
A surveyor would come and survey the land, and then they'd say to someone like, "Spot on, can you build this for us here?" And he'd go, "Yeah, I tell you what, give us me benchmarks."
When the river floods, I don't want to go in my living room.
What they say to me is like, we're going to put some datums around the site, and like, don't worry, like, it may look like it's bending, but it's not. It's actually straight. So when you get to the top on the plate height and you put the rafters on, like, they might not all line up, but that's all right, because obviously we're aware of the fact that it will be bending.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared.
Just call your local surveyors. Ask them.
Yes, call them. They'll agree with me. Everything I've said to the T. Nothing being incorrect. Nothing.
They won't agree with you talking to a bunch of flat earthers for hours. You left that part out.
That's true. That is absolutely true.
I don't think they'll be concerned about who you're talking to. I wouldn't bother telling them what you do in your spare time. They won't really be interested in that. Just stick to like asking them about surveying and how they survey. That'd serve you better, I think.
What is the fundamental need for a surveyor? Is just to plot out a section of land and...
Yeah, they give you the datums within the land in order to tell you how high, what the land's doing.
So that just pick a reference point and then just give you the variation of the land.
Yeah, and they'd let you know for drainage and all of that. Like where you needed. I presume they would have datums for the drains that are already there, so you need to plot out your drainage to meet the big drains. So you'd have to know all of the different levels.
Main drain in the road, for instance, and then they'll come and like put the.
So have you ever heard of these state plane coordinate zones?
What?
SPC 83, for example.
Is that America? That because we're both UK, so.
You probably haven't heard of it.
No.
So SPC 83, NAD 83, and its reference ellipsoid GRS 80. I mentioned that earlier. If you understand this, they break every little segment of the Earth into little squares, and they basically break down those squares and tell you what the heights of all this land looks like.
Yeah.
Based on the geoid and based on the ellipsoid.
Why do they give you two different models? You're not sure what? Why do they not just give you a map of what the land is? Like,
because gravitationally, the land, like I mentioned earlier with the St. Lawrence,
two different shapes of the land.
You're talking over me again. The land will not follow the gravitational, basically the effective shape, because we care about runoff. We care about where water goes. So that's what we need to know about the geoid and the spheroid, or the ellipsoid, rather.
All you need to know.
Now we're talking about the actual.
So as you open that link, please. If you open the links, you can find out what I'm talking about and how it's broken down accurately, and it's depicted in a very easy to understand way.
It's not easy, is it? If there's two different models.
See, this is it.
Surveyors will just give you a map of the land. They'll go like, this is what you need to know.
There's a difference. I understand it. Others here understand it. You don't understand it.
It makes perfect sense to me in your model.
No, we measure it though. We can actually measure it.
You don't.
Yeah, no, we do. We do. GPS for land surveyors. Go look it up. You can see about the equipotential heights. They point on the Earth's surface perpendicular to the ellipsoid or perpendicular to...
Did you hear what I said before about in the UK, 2003? They made a map, an OSNet map. That it's a coordinate map. So they just transposed all of the details that they had for surveying onto this map. And now when they plot your position, they can do it within 1 to 2 centimeters.
But the problem is
because of the map.
The ellipsoidal heights are not gonna meet the equipotential heights.
It's just one map.
You understand?
It's just one map.
Once again, every time
nobody's ever building anything big enough for that to be an issue.
Yes, your house.
Your house.
Hold on. Your house next to a stream that maybe floods every winter once or twice. That is an ultimate importance to you to make sure you have the geoid take into account rather than just the ellipsoid. And you can measure it with an instrument.
But that's really obvious. I don't need
Hold on. You have the topographical surface, you have the ellipsoid, and then you have the geoid. These are different. These are different.
No, right, listen, this is what you got. You got a water level, yeah? And that's a datum that they know of. It's been
that's not the data.
Hold on, don't talk over me. I don't like it. Right, so there's a datum that they know of that is water level or mean sea level. Yeah, so these levels are already there. Yeah, they're based on water, which is actually level, right? So when you're building a house, you're aware of the height in which water rises if it's a flood area, etc. So there's nothing about geoids and ellipsoids. It's water level.
You're being naive. You're being naive.
No, you're overcomplicating.
No, you are being naive because that's exactly what they don't do.
It just doesn't seem to be something that you would need to take into account.
You tell a person.
You could just work off a flat.
They don't take it into account. It's only in the minds of Discord lunatics.
Attention span of something greater than a flea. You open that link and you go to like the 3rd section where it talks all about the ellipsoid verse and the GPS for land surveyors. Let me finish. Don't talk over me. It goes from the GPS receiver, GPS for land surveyors, and it compares that with the geoid. Once you understand this, you will get it.
Just go and ring up your local surveyors and ask them if they've ever.
Yes, they understand this very well. And there's a part in the test I gave you guys on that paper that talks about this, what you would do if you understood what the geoid looks like near your house, near a river. And it's very important so that you don't flood your house.
There are hundreds of examples of this sort of observation.
Exactly. Oh, you mean like this one? You mean observations like...
That's unusual, though, guys. You gotta at least admit, this isn't the norm. The norm is a close horizon.
A close horizon? Well, that's not the norm at all.
Observation. There's 3 miles away.
Who assumes a close horizon?
Is it a whale?
There's 20 miles away right there. There's my 20 miles away.
Is it a whale?
There's my 20 miles away. I have a picture. I got it before you did.
What is it?
A 200-foot boat that's missing. All I see is the smokestacks up top.
Oh, it looks like a load of sort of mirroring or something happening there.
No mirroring. It's 20 miles away.
It looks like a bit of swell there as well, I think.
No, the swell wouldn't do that.
A little bit of a wave close.
Picture 4. There we go. That's what it was. Suddenly, no distortion.
Might have been
smokestacks are gone.
It could have been a geoid lump. Do you reckon?
Oh, it could have been on that geoid.
Yeah.
100 meters.
Definitely massive geoid lump.
Pictures up again of that geoid.
I'll get you the picture, the one that'll cover that.
All the way around the world.
I've got you covered, Zanik. We're right here.
Nope, that doesn't do it.
There's so many ways to explain it.
All I'm saying is that level is massive, man.
There you go, that one. That sea surface. It could be on that. See the geoid lump on the right hand side? There you go, the boat's on the other side of that. The sea floor topography could have had a bit of a lump.
That's a great example, yeah.
Actually, have you guys seen the
He says for typical boundary survey, it doesn't matter. That's what he's saying right now.
Yeah. Yeah, they don't figure it in. It's
That's
not
what I was saying before.
There.
all the cars in the parking lot just like kind of roll into the middle. You know what I'm saying?
You'd have to be building something ridiculously massive to need to counter that in.
You don't. That's the whole point.
No, you don't.
They
you
don't
either.
figure it in everywhere.
Only in their model.
Yeah. No, you would need to figure it in. If you were doing drainage, damn right you'd have to know about that. And when you think about drainage as well, drainage would work from a different point. Because if level curves, then what does the water level do? And like the water wants to flow which way? It depends where you're stood. It just doesn't make any sense for drainage.
You won't understand that.
Yeah, I don't believe water's curved, hey.
Yeah, it just can't work.
I don't see it demonstrated either. It should always be demonstrable.
But can you imagine if so if you want a ball and you've got your house, yeah, and you want to run a drain to a lower point, yeah? So the water's running down to the drain, isn't it? Yeah?
Yeah. Yeah.
Yeah, of course.
Right, from my point. But so if I was at that drain and I wanted to run a drain to my house, yeah, the other way, how would you work that out?
Yeah, it'd have to go the other way. It's mental. It's like if you run a drain a mile away and you have it running down 8 inches in that mile, then you walk to the other end of it.
Yeah.
Then, like that 8 inches on the model that Zanuck has disappeared.
Exactly.
It's not run down at all.
That's your evidence.
And the 8 inches would have to go the other way downhill.
What are you talking about?
It's mental. Your model doesn't make sense, Zanuck. The reason they don't do anything with your model in reality is because it doesn't work. They just it doesn't work at all.
You don't know. You mock them. You're confused.
No.
Listen to what he's
Where
saying.
is it not used? I just told you it's used on a piece of land near a river. Absolutely.
Zanuck, listen to Bev explain about a level from drainage from one end to the other over a mile. 8 inches full, yeah?
The longer you go, the worse it gets.
Yeah.
No, let's see. Everywhere it can be level every single point of the way. Right? That means it followed.
No, it's drainage, Zanuck. It being level is useless. It wants to drop.
You want to have some, yes, you want to have some change versus level.
Yeah. But if you don't figure a curve in, you're fine.
You don't want every point to be perpendicular to the plumb because that orientation would be stagnation of water.
All horizontals are parallel. In surveying, that's how it works, Zanuck.
Parallel to what?
Sorry, Ben.
A horizontal.
Yeah, you're wrong.
Posted it up again.
You're wrong. Sorry. You're wrong.
I just wanted
That's
to
not the way it works. And I encourage you to call a surveyor.
Zanuck, that's the only way it works, because that's how you measure a change in altitude from another point.
It's above sea level.
No, it's just a difference in height from a datum.
Oh, you're talking about elevation. You're talking about elevation now. Get your words right. Altitude is what we use in aviation. Give us a.
No, altitude is what they use in like height above sea level.
You don't even know. So why do you even start continuing this conversation? We're talking about it for 3 hours now, and you still don't get it.
Zanuck, there's a video for you to watch. I posted. You spawn times. Maybe have a look at it.
And how do you explain away the surveyor saying that he surveys on flat land?
He said he does things over small areas. Even when it came to water, he said a half-mile long lake won't make a bit of difference.
Yeah.
So he asked about the curve calculator. He didn't know. This guy's not a guy dealing with flat Earth people.
Yeah, no, that's the majority.
doesn't.
The majority of surveyors have no idea about the globe.
Stop talking over me. Hey, he's on a small scale. He's a surveyor. He knows how to get bound. His specialty is boundaries. His boundaries. This doesn't deal with curvature. He's not doing land surveyor, things that have to use the GPS datum and curvature numbers from the geoid. I gave you all the values. Read that paper. Do yourself a favor. Learn something.
Zanuck, if it was figured in, do you not think he'd know?
Dirt. You know why you're dumb as dirt? Because you won't open a friggin' document to learn something. So you're going to continue to be dumb until you open a fucking book and learn something.
So in other words, which was the question I think at the beginning of this, is do surveyors take into account the curvature of the Earth? Well, the answer is simply no, because it's not necessary.
No, it depends on the surveyor.
No, it
depends on the surveyor. It depends on the surveyor.
99% of the guys that do
It depends on the surveyor.
Yeah.
It depends on the surveyor. Read the book. There's friggin' thousands of pages of this shit.
Oh, yeah, loads of thousands of pages of shit.
Yes,
exactly.
Because people don't want their houses flooded next to a river.
It's nothing to do with flooding, Zanuck. That's not all surveyors. That's not all they're worried about.
Surveyor that you're talking about.
Go to chapter 3 of the geoid equal potential discussion. You'll figure it out. Until then, you'll be confused.
Rand's Corp had it sussed earlier when he said that, you know.
Zanuck hasn't got a clue.
Open the document. I'll do it again. Here's the document. Open it up. There it is. This is a good paper. I encourage you to read it. Your choice, but I would encourage you to open it up and learn something. This has all your questions answered, especially the last paragraph of this very lengthy paper. Just scroll to the end and you can get all your answers.
If one of us reads it and then based on what we've read, we decide that it doesn't make any sense and we don't agree with it, what do you suggest we do then? Do you suggest that we're just simply stupid?
No. I would suggest at that point to get a professional surveyor to explain to you the things that you're confused about. Doesn't mean you're stupid, just means you didn't understand it. This isn't easy stuff. This isn't like
prove the curvature.
Which surveyor did you talk to, Zanuck?
But I didn't say whether or not I understood. I said, what if I read it and disagree?
Well, then if you disagree, okay, that's a great point. If you disagree, mark down those points that you disagree, and let's get a professional surveyor so we can explain it to you to see if that can change your mind, or maybe it won't. But at least you should understand.
If you get a chance, Zanuck, can you send me the link to my DMs?
Absolutely.
Thank you.
No problem. Really good article too, but it's really well written and it's not too technical.
In Zanuck's presupposed heliocentric model, then what he's talking about is what we should see in that model. I just don't agree with the model because I don't think it's been proven. I don't think there's any evidence for it. In fact, there's a lot of evidence against it.
No, there's a lot of evidence for it too. I've shown you my evidence. So to say no evidence is a lie because I've shown you evidence. You don't have to.
A lot of that evidence is presupposed.
No. You can't just
taking the question.
You can't just toss it out as not evident because you don't like it. Remember, even like how Elijah just said, he could read over it and disagree with it. You can disagree.
That's why we have the scientific method. But
no,
that's not what you're appealing to.
No, that's not why you're scientific.
But at the same time, yes, I can listen to someone and then point out the fallacious reason. So if there is any fallacious reasoning in someone's explanation or someone who's trying to teach me something, if I pick up on any fallacious reasoning or point it out, that's an issue. You can't say, no, it's not an issue because of all the other fallacious points that make sense when you put them all together.
That means you're paying attention and you're using your reasoning to decide what you're listening to is either makes sense or doesn't make sense. But I hope that you would, if you question something, that you ask questions to clarify whether you're understanding it, which the person that's presenting it is presenting it to you.
I thought it was interesting. He said we come up with all these complex explanations, yet he, as if he thinks the curve is like the simple explanation. As if living on a ball is the simple explanation.
It works.
Yeah, but that's because you can't explain.
Imagine the water all being level and the land rising from it.
Yeah, what? You have no explanation on anything. However,
you guys don't even have a
say
map.
it there. It's
yeah, we have every map.
You can't explain anything.
Do you guys have any curved maps?
It's called a globe.
No, that's a globe. That's a model, like we said before.
Well, you can project the globe on a flat map.
Actual map.
Yeah, you can project the globe on a flat map.
On globe or on like a curved map?
It won't be a curve if you want a flat
you
map.
You can't map a curved surface on a flat map, can you?
You can, but
no, you
It
can't.
won't be 100%.
Not accurate, right?
100%
But
correct.
the maps that we have are
But if you're gonna have
really accurate, especially
Yeah,
in
but
the
if you want
UK.
a map-
Super accurate.
If you want a map over your hometown, it's gonna be pretty much.
No, like the whole of the UK.
Yeah, well, that is also
Shabby.
going to be how much.
Because that's all they do is they take little parts of it and they change the map that way, don't they? That's where they print different bits. You can have a number.
How much area is UK compared to the rest of the globe?
Oh, can you say just the UK must be flat then? I mean, is that
No,
I can fully accept that if that's what you think. Like all the water in the UK level. Did they ever do any on curved maps? Any old curved maps? And we thought we best map this onto a curved surface. Otherwise, it won't be accurate at all.
It's not accurate. All maps aren't accurate.
Yeah, I would say that's how you know it's flat, right? Because every flat map is distorted. To me, that's base one for flat Earth. Yeah, I would say that's how you know it's flat, right? Because every flat map is distorted. To me, that's base one for flat Earth. To say it's flat, you got to at least, the very, very least, give us a map. That's step one.
Every map is flat. That's because the water level works and the contour lines work. There's no distortion.
You can't say that.
There's no distortion.
Hence, the Earth is flat.
There is no distortion.
Sorry, man, that argument is.
All distances are calculated by straight lines.
Yeah, but those aren't accurate, are they? Though.
Yeah.
Not over long distances.
In the UK.
No.
Yeah, we've probably got the most accurate maps that there is.
When we traveled to Korea, I couldn't use a flat map for that.
Do they have a curved map? And for Korea?
No. No.
I don't know what the Korean surveying
I
people
don't
are
have a
like.
curved map.
But that's what it depends on. It depends on the quality of the surveyors.
But the shortest
make the map.
It looks like it's straight on a flat map. So that should be like some kind of hint that the Earth is maybe not based on that.
The shortest distance between 2 points is as the crow flies on a map, and you measure it. That's why maps have scales on them, so you can accurately plot them, the points.
Yeah, but I'm talking about, for example, when you're moving at the northern hemisphere, when you have the shortest distance from A to B, that's not the same on the flat map as on the globe. On the globe, it's a straight line. On the flat map, it's not a straight line. Yeah, but I'm talking about, for example, when you're moving at the northern hemisphere, when you have the shortest distance from A to B, that's not the same on the flat map as on the globe. On the globe, it's a straight line. On the flat map, it's not a straight line.
I haven't got a clue what you're talking about. Can you do some pictures? I don't understand what you're talking about. The distance between one point and another point isn't a straight line on a flat map.
No, that's because you can't, as you said before, you can't present a predictable globe on a flat map.
Yeah, that's why they don't. That's why they just map the land and put it on flat maps. That's why they make flat maps. That's what I'm trying to tell you.
They make flat maps because
the people that map the land, that is the best way to represent the land that they map.
For what area are you talking about?
For every map maker, that's what they do.
But look, here's another thing you're not taking into account. Nobody uses a ball to navigate ever. It would
No,
have
they
to
use
be
they're
connected
using a
onto
computer-based map system, or they have maps.
But this is what I'm saying. You can use a piece of paper. You can use a piece of paper
Yeah.
to get you from point A to point B.
But no, it
but you
won't
can't
work over
use
the
a
whole
ball.
over a large area though.
Yeah, it does.
And
That's
you
what
can
they've
use a
always
globe.
done in the boats and everything. They had navigation charts. You never seen them with the compass and the protractor?
Yeah, but those
Yeah,
doesn't work
straight
over long
lines.
distance.
That's what they were doing.
They don't work over.
That's
long
all they ever have used. All maps are
yeah,
flat.
but those are based on a globe.
No, they're not.
Initially.
They're not.
Okay,
Have you
so
ever seen an atlas and you see the distortion of the projection?
But if you open up a flat world map, why are they distorted at the top and at the bottom of the map?
You mean the Marcader projection?
For example.
Yeah, because they've been projected from a globe. They're absolutely mental. Nobody in the right mind would use that as a map.
Not over small distances, no. It's not practical.
It's not practical at all because it's a projection of a model.
No.
That's why all maps are flat.
Of the globe.
Because they're a better predictor for what the land's like.
But why
All
is
maps
the
are
globe?
flat maps.
Yeah.
Why is the globe? What is the globe?
The globe's your model. That's not our problem.
No. Why is that
right.
predicting?
Why do
the
you not
shortest
use a
street?
globe for measuring things? Why do you not have any curved maps that you can turn to and go, look, this map is way more accurate than your flat maps because it models the land properly.
If I'm going for a 2-hour drive, it doesn't matter if I use it.
Why can't we even buy today a 2-scale globe model? Why is that not possible?
Human globe?
Yeah, a 2-scale globe model.
What do you mean by 2-scale globe model?
Like 2-scale, like you can get a to scale car model.
You mean you mean to scale? Okay, you can just buy a globe.
No, that's not to scale.
Yeah, it is.
No, it's not. It's not.
Yeah, it is.
It just says it's for educational purposes only. It's ridiculous. It's not. That's not 2-scale.
Beltrami did indeed succeed in constructing such a map, but it's the version constructed by Henri Poincaré that I'd like to show you. Like the maps in the usual atlas of a globe, distances are distorted. In this case, the whole of two-dimensional non-Euclidean space is depicted inside this disk. As I move outwards, distances appear to shrink, but that's a distortion of the map-making process. We non-Euclideans don't actually shrink, nor do we ever run up against an edge.
Looking out upon the shore, I found balance and so much more. It's getting clearer all the time. All we see are all these dead straight lines, and show me what's in reality. And I won't compromise between the truth and lies. This is where I make my stand. Please don't take me to your la la land. It's all about geometry. All we see is horizontally. Show me what's in reality, and I won't compromise between between the truth and lies. Show me what's in reality, and I won't compromise between the truth and lies. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy. And you can bend reality into what you think your cog deceives. Something's happening to me. Don't remind me of how things used to be. We don't need no sycophants. Aren't we all